Hello guys. So I was going to teach you guys elimination, but I decided it would be better to teach you substitution method first and then teach you elimination, because elimination will incorporate stuff from substitution method. So I'm going to teach you substitution, then we'll go back to elimination. All right, so let's go come up with some equations. Let's go with y equals, this is my system of equations. To y. Apologize. This is my system of equations. We got x and we got y. We got x and we got a y. Perfect. That's all we need. So, how substitution works is right here we have. Apologize. My marker thing is kind of small. Anyways, so what we have here is that y. For substitution, you have to find a variable where you can substitute. In this case, we can substitute over here. Because y, right here, y equals 2x minus 2. Y equals 2x minus 2. What does that mean? That means that y equals 2x minus 2. So that we can plug in 2x minus 2 for y in one of the equations. In the other equation, in this case, we can plug it in this equation. So we're going to plug it in right now. 2x plus 2 times 2x minus 2 equals 8. You see what I did there? This is essentially coming from here. Boom. It comes from there. The 2x minus 2 gets plugged in instead of y. You see? Instead of y becomes 2x minus 2. All right. Now you just have one variable. Now you just have this variable x. You can solve for x. You know how to do that. First, we have to distribute the 2. So we have 2x plus 2 times 2. It'll be 4x minus 4 equals 8. Then we're going to add 4, add 4, add 4. So then we have 2. So add 4. And then we can also combine like terms at the same time. 2x plus 4x, so that's going to be 6x, equals 8 plus 4, 8, 9, 10, 11, 12. Oh, look at that. I skipped this step. I will write it out for you guys because I'm nice that way. Divide by 6, divide by 6. X equals 12 over 6 is 2. 12 divided by 6 is 2. X equals 2. What? We already have one of the coordinate pairs. So what this means is that the solution is going to be a coordinate pair. So first coordinate pair we have is 2. Now we just need to find the y variable. All right? To find that y variable, what we need to do is we need to plug this 2 in for another equation. In this case, let's plug it in over here for x. So let's plug it in over there. All right, so now I'll do this work over here. All right, so y equals 2 times, instead of x, we're going to plug in 2 minus 2. So then y is equal to 4 minus 2, which is equal to 2. So y is also equal to 2. Okay, we got our solution. That is our solution right there. 2, 2. Y is equal to 2. Cool. All right, so what does this mean? That means that, remember from the graphing video where we drew both the lines and where they intersected, that's the solution. That's where these two lines are going to intersect. Why don't we prove it to you right now? All right, so in that case, let's erase everything. Clear out the whiteboard a little bit for us. So let's graph these. Let's go and graph these and see if it actually intersects at 2, 2. At 2, 2. All right. So first, let's graph the first one. Let's go down 1, 2. Boom, that's a y-intercept, and then we'll go up 2 over 1, right there. Up 2, 1, 2, over 1, there. That's gonna be our first line right there. Cool. And so let's go 1, 2. All right, so, and then 1, 2. It might not be exact, might not look exact because, you know, I'm drawing this by my hand, so, but we know that the solution is 2 over 2. Let's figure out if it's approximately there. All right, so then we have 2x plus 2y equals 8. How do we solve this? Haha, yes. There's a standard form, we can solve it easily. If you don't know how to do this, watch my standard form, solving standard form linear equations video. I have that as my previous video, check that out. All right, I will actually link it in the description. I'll link it in the description, all right? Or I might have a pop-up. I'm new to this YouTube thing, we'll see. We'll see what happens, all right? All right, if we make x 0, and we make y 0. If we make x 0, if that's 0, 0 times 2 is gonna be 0. So we just get 2y equals 8. So that means y is 4, sorry. Y is equal to 4, I should have just written a 4 there. Because 4 times 2 is 8, perfect. If y is 0, then it's gonna be 4. Look at that, 4, 4. Awesome. So, it'll be 0, 1, 2, 3, 4, right there. 1, 2, 3, 4, right there. That's a line, right there. We're gonna go that way, there. All right, we see a next intersection point. What is that intersection point? It looks like it goes 1, 2, goes here. Look at that, right there. And 1, 2, right there. 2, 2. What? I know, that's the solution. That is the same thing as that. They're the same. What? That's proof that the substitution method actually works. So, if you don't believe me, have a look back how I solved that. We're gonna actually solve another one. We'll solve another one. The substitution method is, although it's a lot of work, it's not that difficult. It's not that difficult, especially if you know how to solve for x, essentially. That's all it is, solving for x. All right, let's do this once more. Sure. All right, that's gonna be a system of equations. I'm just coming up with these out of my mind, so I don't know if they're gonna come out even, but hopefully they do. All right, so this is y minus 4. I'll make that 4 clear for you guys. Y minus 4. All right. So, let's do it. All right, so in this case, we have x, and it equals y minus 4. So let's plug that in for x. So we're gonna plug that in for x over here. So we're gonna plug that over here. So we got, again, I'm doing this all over again. All right, so 4x plus, we're plugging in 4x. So it's not going to be 4x anymore. It'll be 4 times what used to be x, which is now y minus 4 plus 2y equals 24. All right? Distribute it. 4y minus 16 plus 2y equals 24. We have 6y. I'm skipping some steps here because I have limited board space, but essentially I'm combining the 2y with the 4y to make 6y, combining like terms. And then we have minus 16, so minus 16 equals 24. I could have done that step as well, but it's fine. So we're gonna add 16, plus 16 plus 16. So then we got negative 16 plus 16, that's gonna be 0. So we got 6y equals 30, no, 40? Wait, 40. So then y is equal to 40 over 6. 40 over 6, or 20 over 3, equals 20 over 3, which is equal to 0.6. Oh, wait, it would be 6 point. Wait, let me see. 3 into it would be 6.666. Repeating. Off the top of my head, but I'm just gonna keep it as this. I might have been wrong there, but anyways, it's 20 over 3. That's the exact exact answer. This is so now we got y equals 20 over 3. That 20 over 3, you're not going to get that as an exact solution when you're graphing it. How are you going to see 20 over 3? How are you going to see a decimal point? There's no way. Anyways, so that's the value of this algebraic way to solve the systems of equations. All right, so now we got y is equal to 20 over 3. All right, so now we can plug in that for y. So we're going to plug in y. Which equation do we do here? We use this equation. So we're going to plug y into the other equation. We're going to plug the y into the other equation. So we're going to plug this in for that guy. So x equals 20 over 3 minus 4. Oh, we got fractions here. What? Okay. So then x is equal to, how do we solve fractions? We gotta have common denominator, right? So we got 20 over 3 minus, what is this gonna be? This is also gonna be over 3. So we're gonna be multiplying 4 by 3. 4 times 3 is 12. Perfect. 20 over 3 minus 12 over 3. That's gonna be 12 minus that is gonna be 18. 18? No, 8. 8 over 3. That is the solution for x. 8 over 3. X equals 8 over 3. Just to confirm, I want to confirm 20. I don't have a calculator to check it, so I'm going to do it by hand. 20, we're going to borrow from that. It's going to be 8. Yeah, it's 8. I was right. Always confirm your work. Even though you can do it in your head, always confirm your work, especially on the test. You don't want to get that thing wrong. All right. Now we got the two corner points. So where are the two lines going to cross? They're going to cross at point 8 over 3, comma 20 over 3. There's no way you'd be able to find that solution through graphing. That's the magic of substitution method. All right, now we know how to substitute stuff. Let's learn how to eliminate. I'll see you guys next video. Have a good one. Like, share, subscribe, all that jazz. All right, see you.